5G is very challenging because in order to be able to support gigabit per second, we have to shift the frequency from lower gigahertz, where the LTE is, all the way to millimeter wave. Now, by going to millimeter wave, we're basically adding a lot of challenges to the front end of 5G system. Basically, this system now you cannot go ahead and design the same way that you have been designing your IC, your board, your substrate, your antenna. This is a completely new kind of area, and it requires a lot of innovations. We're actually trying to come up with innovations and solutions that can address an efficient, high-performing kind of 5G that can give you high capacity as well as high coverage, and come up with sort of system solutions that can help you with overcoming some of these challenges that exist with millimeter wave. For example, the penetration issue, because these signals get basically blocked by buildings, by trees, and you can lose connections easily. That's why you have to have a beamforming phase array kind of solution that can not only transmit enough power to give you enough range, but you should also be able to get around the line of sight kind of issues. So we have been working to come up with innovations, and we have been looking at it as at high level, as a system. Basically, we're treating this whole front end as one module that can address and make sure that you can perform, and it's not very high cost. We have to be able to test and characterize this, right? How do you know this even works? This is a completely new area. And not only these challenges exist, after you address them, there has to be a way that you can actually test them. That's why we have been working with Keysight and using their equipment to be able, for example, to apply the modulation, the 5G modulation for pre-5G right now, and eventually it's going to be for the NR. We have been using the equipment to basically characterize our 28 gigahertz solution, the noise figure, the compression point, the gain. And the good thing is that some of this equipment actually give you all this capability in one equipment. So you can use one equipment to do all these measurements on the IC. You can also use the equipment to be able to do some demodulation on the 5G modulated signal that you get from your receiver. And it makes it easy for us to be able to characterize this and make sure that this system works.